Okay. Now. Oh. What am I supposed to do? I don't understand. It's not letting me do anything. Oh.
Once you've finished recording your observations in Table C of your student guide, click Next to examine how electrical currents create magnetic fields.
Next.
In Step 9, you'll construct a simple circuit and use it to explore how currents create a magnetic field. Follow the on-screen directions. Start by clicking the tape.
Okay. Clicking tape. You're going to tie them both to positive and negative. Yeah, it's kind of like charging a car battery. You're going to tape it to the light bulb, and then the light bulb should turn on. Oh. There you go. Just like that. Okay, right there. Oh, whatever. Nice. See what it does? It switches from north to south. Just do that, and then it'll bend, so I can stick this under here. See? It's staying the same. Oh, continue. See? There it goes. Now it is moving.
Once you finish recording your observations in Table D of your student guide, click Next to make an electromagnet.
Okay. Next.
In this final part of the lab, you'll use an electric current to make an electromagnet. Follow the on-screen directions. Start by dragging the screwdriver toward the paper clips.
I'm not stupid. Okay. Did. Make a coil out of it. So then we'll pull the screwdriver out. No, maybe not. Okay. We're gonna tape the ends to it. One and one. No, both. Okay. Simple enough. It's gonna pick them up. Look at that. No, pencil doesn't do anything. It might. Well, no, the wood. Why is it glitching out like that? Okay. 1, 2. Okay. Now, see, it doesn't pick up anything. Because it's not metal.
Once you've finished recording your observations in Table E of your student guide, click Next to make sure you're ready for post-lab reflection.
Okay. Oops.
Now make sure you're ready for post-lab reflection. Did you record all the data throughout the virtual lab experiment?
Yes.
Now that you've recorded all data throughout the virtual lab, you're ready for the follow-up assignment, in which you'll reflect on the experiment you just did.
Oh, yeah. Okay. We're gonna go to home. I'm gonna do this. Open. Turn. Okay, lab report. And we're gonna go and save. Alright, that's okay. We're going to go to Laboratory Rubik. No, this is an entirely different thing here. I can't save this one? Okay. It was downloaded then. That. Then it's all downloaded, so just hit submit. Okay.
In this virtual lab, you observed both electric fields and magnetic fields and demonstrated their effects on objects. You also not only visualized each one of these, but were able to investigate the interaction between them. Now, let's take a look back at the goals we set out at the beginning of the lab. Let's review the goals that we began with at the start of this laboratory. The main goal was to explore the concepts of electric and magnetic fields. Now, we did this in several ways, so we broke the lab apart into 4 pieces. For the first one, we used a bar magnet to identify the presence of a magnetic field, and we observed magnetism with different objects. Second, we observed electric fields as static charges by seeing the effects of static charges with some common objects. Next, we examined how a magnet can generate an electric current. And finally, you constructed your own electromagnet in order to investigate how an electric current can generate a magnetic field. Now let's take a look at our conclusions. We began with the hypothesis that if a magnetic or an electric field is present, materials that generate these fields will interact by either attracting or repelling each other because of their magnetic or electric properties. So, what we can say is this. First, our hypothesis was supported by the data collected in our experiment. Next, that electric and magnetic fields were observed. Electric fields were observed using compasses near closed circuits, and magnetic fields were observed using iron filings within a magnetic field. Next, when these fields were present, there were either electric or magnetic attractions or repulsions between them. And finally, we pulled it all together and were able to build our own Let's review our own electromagnetic.
I'm gonna search some. How do scientists find iron filings? Are very small pieces of iron that look like a light powder, yeah. From metal working, so it's like leftover unused metal, huh? After they like make metal beams, I guess, out of iron. There's a magnet right there. Yep, okay, that makes sense. Let's continue with our video now.
And this further demonstrated the relationship between electric fields and magnetic fields. Now, let's consider a real-world example. Electric motors. Now, electric motors use the principles of electromagnetism to move machines. They can be the smallest toy that a child is playing with,
or
they can be the motors for the cars that we drive every single day. And what happens is a current is being produced in a coil, and that coil is wrapped around metal and generates a magnetic field. And that magnetic field is attracted to the 2 circular magnets that surround it. Now, while that current is being produced, that coil is actually attached to an axle, which is allowing that coil to spin. And it's spinning because that coil is being attracted to the 2 halves of the magnet. Now, if you alternate the current, positive side becomes negative, the negative side becomes positive, then you're going to force that axle to keep spinning, because that coil is going to continually try to align itself within the magnetic field of those two circular magnets. So, as the axle continues turning, it can turn other parts of the machine, for instance, the wheels on a car. And the more efficient and the faster the alternation of the current, the faster the axle can spin and the faster something can move. And if you'll recall, we had an example previously in the lab of an image of a hydroelectric dam. And it's actually the movement of falling water through that dam that moves magnets and causes them to create electricity that's distributed to people in the community.
Nice, I have completed the lab experiment and the summary. So tomorrow I got a unit test, and then the day after I got that big exam coming up. That's gonna be tough. So I'm gonna